Okay. So I'll have my slide to basically guide me, and then I'll have my ID. So let me know if you can see the screen. I mean the editor, and if I need to increase the font. Yeah. If I need to increase the font, let me know now so that I can do that. And let me show you another code where I have some code. Do you think this is the um, right size of the font, or do you need increased it?
I think it's all right. It's good too.
Okay, perfect. So I'll be presenting. So this is going to be a light session. So I'll start with the very basics, and then I'll give some, idea how the virtual threads works, and also, demonstration, give you some demo. So what I'm looking is, if you have questions, feel free to, um, ask questions anytime. I'll try to accumulate the questions when I'm speaking. If I cannot do that immediately, I'll definitely try to accommodate them end of the session. So yeah, anytime is good time for asking questions. Um, but another thing, another caveat is, I'll probably not be able to answer all of your questions, but I'll try my best to, answer as much as I can. And if I cannot answer some of the questions, I'll keep note, and maybe some other way I'll try to answer those. Maybe writing, some form of writing, blogging, and all those things. So, all right, without further ado, we can start, I guess. Um, so as you can see, the title says virtual thread ushering in a new era of concurrency. And I personally believe that. So this is definitely a new era in concurrency, especially in Java. All right. So I'm gonna give you a background first. So the whole presentation in two parts. First part, I'll just try to summarize a bit of how concurrency works in Java and what problem we have currently, and then the next part, basically in the second part, we're gonna explore some of the benefits and some of the way how we can improve those problems using virtual threads. So moving on. So first thing is, we have um, you know so let's yeah. Anyway, sorry, I was looking at the comment and someone made a comment over here, and my attention goes there. Anyway, I'll definitely look at the comment later. I mean the questions, I guess. So, over here I said that Java is made of thread, and I believe it, and I guess every Java developer pretty much would agree with me. You know, and the reason is, let's see how why I'm making this statement. First of all, from the day zero, when Java first released the first version, it introduced thread, and back in the day, concurrency was very difficult to achieve, especially if you want to do it using C++. It was a tremendous work, and Java made it really easy. And that's, I believe, one of the reason why Java is what today. I mean, the most popular programming language, right? So yeah, another question gets to be, is what our thread usually is, right? To simply, if you say threads are basically a unit of executions in Java, that means a program that you write, it needs an execution environment. So threads are basically the execution environment where you write a code from start to end, and the thread executes that serially in that particular context. So if we have more threads, that means basically we have more execution environment, and that actually give us a lot of benefits. Mm, and that means we can do more things simultaneously. That way, kindly I'm doing, right. For example, I'm speaking, I'm sharing slides. At the same time, I'm probably coding, and some other apps probably doing some various other things. So this sort of concurrency is achievable using threads. If we have more of them, we can have more execution environment, and we can do uh, this kind of things more. So which is in a everything basically. So moving on, and if you explore all the layers of Java, you will see threads are pretty much ingrained in Java ecosystem. It's in all layer. Especially if you even start with the basic Hello World main application, you'll see your main application even executed by a thread. And if you don't believe me, I can just show you a quick demo. I'm pretty sure you already believe me, but I can just show you a demo. So what I'm gonna do is print the current thread over here. So what happens over here is from this curly brace to this curly brace, anything I write is going to be executed by a thread. And for this instance, it's going to be a main thread. So if I run this program, and as you can see over here, it's printed the name of the thread, which is main thread. So basically, even if you don't, if you are basically a entry level programmer of Java, you don't deal with all this concurrency. You are still doing concurrency in Java, and you are still dealing with threads. You are dealing with exceptions. You are debugging. You are profiling. The garbage collection happening out of the box. All of those things that happens because we have threads in Java. So we in nutshell we can say threads are in all layer in Java platform. So moving on, I already showed the demo. Oh no, I haven't. So how do we create threads? It's easy. Like if you see here, I can just create a new thread, something like that. Var thread. I'm using var. It's a new it's called local type information, and I like it. There are other people who doesn't. Um, that's totally fine, but I really like it using in local context. Anyway, so this is how we create thread. Basically, we create an instance of new thread, and we pass a lambda expression over here. Usually, you previously used to pass the runnable, something like that. Replace with an anonymous inner class. So it can, whatever you write in this run method is going to be executed by this new thread. So that's the idea, and you can, transform this into a lambda expression. So that's obvious, right? All right. So whatever we write, hello Jcon, right, is going to be executed by a new thread. So if you want to see the proof, you can just print thread.current thread, right? And thread.start. Let me wait so that it finishes the work. And if I run these applications, obviously this new thread, it's going to be printed. Basically, it's a new thread. And I haven't named this thread. If I want to name it, then it will print the name that I, set over here, which is, let's say, jcon demo. If I run this now, I'll see its name is jcon demo, and it started from the main thread, basically, right? I can just print the get name, then it will print only the name. It will not associate other stuff over here. So as you can see over here, it's printed the name. So this is how we create threads pretty much in Java. And it's simple. So in this thread, whatever we pass from this curly brace to this curly brace inside, whatever we write, it's going to be executed by that particular thread. So over here, what main thread is doing? Main thread is doing is creating a new thread and then calling the start method and waiting this thread to finish once again. So that's what it's doing. Moving on. Sorry. So, and I'm not going to run these applications because what I'm trying to convey with this, this little demo over here is trying to find out that Java threads are not basically the Java thread. They are basically underlying OS thread. It's a wrapper. It's a thin wrapper. So in Java, threads are not managed by Java. It's not Java construct. It's basically when we create threads, we ask operating system to give us a thread, and operating system basically manage whole thing, scheduling and everything. And that's it. We don't control the regular threads in Java. We just the responsibility is on the shoulder of operating system, and we can demonstrate by using, if you take the thread dump off, and you will see something like the PID and NID. These are the mapping basically. So what happens is our Java thread and operating system thread has a 1-1 mapping. So that's the idea over here I wanted to show. But let's skip this slide. Okay, so the next thing that I want to share is threads are expensive. The way we are doing the traditional threads are pretty much expensive. Why is that? Let me explain. Uh, so what happens is when we create a thread, it takes like 2 MB of memory outside of the heap. Although this is not a problem, we can create a lot of thread with this, because ultimately in operating system most memory are virtual, so we don't have problem even if we have a lot of threads with these 2 MB of memory. But operating system every operating system has a upper limit. So they basically, put a threshold. It depends on operating system to different operating system. They create a threshold that we cannot create as many as we want. We have a limited number of threads. And the other downside is if you have a lot of threads, that means operating system will have to, schedule them, and there is a cost of overhead of context switching, right? And this will, take some time. So, if you want to improve the performance of a particular application, if you keep increasing your number of threads, it will not obviously going to work. At some point, it will start downgrading the performance overall. Because the other issues, for example, context switching and the memories, all those things. So the idea is we cannot create as many as we want. So from this things, from this limitation, you can as you say that threads are basically a limited resource, and it's a expensive resource, and obviously we want more threads, especially if we need to write a Java applications. Java web applications where traditionally the way we do things is when a user sends a request, we hand over that request to a particular thread, and that thread basically takes care of everything. This is the easy model, and pretty much this we have been doing this way for many years. And the reason is it's easy to debug, and it's easy to manage. Although in recent years we have created many interesting alternatives. For example, React Java is one of them. I'm not going to talk about it here, but yeah, that's an alternative. It has a lot of downside as well, but the traditional way is much more easier and much more easy to manage. And if we are doing things in traditional sense, that means the throughput of that web application you are writing is pretty much managed by, or pretty much depends on the content connection you can do. Since in traditional way, each content connection is managed by a particular thread. That means if we want to increase the throughput, we need more threads, right? So let's say I'm just saying theoretically over here, if a modern operating system can handle millions of contents connection, that means we can have in a millions. The throughput is going to be really high, right? But then again, we are limited by the number of threads because we cannot create as many threads we want. So basically, if I want to summarize the whole thing, the throughputs of traditional web application depends on the number of threads you can create. So here's the demo. I'm not going to run this application over here because it might impact the streaming. So just keep, you can copy this code and mm, try yourself. But what I'm saying is it's just believe me for now for this presentation. But yeah, you can experiment it later. So over here in this code, what I did is I wanted to create as many threads as I want in my current machine, right? So what it is I'm for while loop, I'm creating threads and then I'm just parking it. So after a while, I'll get a out of memory error, which is basically unable to create native memory, possibly out of memory, or something like that. You are going to get an exception. So I tried this program in this configuration, which is a MacBook Pro with with 16 GB memory, and yeah, and I was able to create 4,000 threads. So if we want to increase the throughput in traditional sense, we need more threads, right? But we are pretty much limited by the fact that we cannot get more than 4,000 with this configuration. It can vary, but there is obviously a threshold. You cannot cross that threshold. Um, so I want to share a misconception over here, which is the reason why we cannot create more threads is not about it takes like 2 MB of memory outside of the heap, uh, and it doesn't. If we don't have a lot of memory, we cannot create that. It's not that. It's just operating system create a operating system control the limit of threads, how many threads you can create. It's not related about the available memory, because you can create a virtual memory, right? What I did is, for example, this text size over here, for this part, when I'm doing this experiment is basically 1 MB, right? And I tried with, increasing the size of, stack size in the thread. And even I tried with 1 GB per stack size, and still the amount of thread it was able to create the same. So I just wanted to share that information over here. And I have created a blog post related to this, which I would like to share with you. Just give me a second. Let me find that quickly. Mm, just give me a second. It was okay. Yeah, I found the article. I'm gonna paste it on the um, uh, where do I paste it? That's a good question. In the chat. Okay, so you can read that article later, but just I wanted to share that. Okay, so moving on. Yeah, looks like we don't have much time. We already spent 20 minutes, so I'm gonna go ahead fast from now on. Okay, so basically, I'm gonna skip the demo over here. So the demo that I wanted to try is basically how many, how can we improve um, the the. So basically, from now, what I have, if I summarize the whole thing, what I have seen so far, what I have said so far is, in traditional sense, the number of, I mean, the throughput of web applications is depends on number of thread we can create, and we are limited by the number of thread we can create. So that's the problem, and that's why we have gone into different alternatives. For example, reactive Java is one of the alternatives. Although reactive Java solved our problem, the very problem that we are dealing now is solved by the reactive problem, but it introduced other problem. For example, if you want to debug a certain part of your code, it's become nightmare. And from the stack base, if you take a thread dump, you'll never know which particular code work in that particular. Basically, finding the problem is going to be difficult. And secondly, the code also become difficult to mind debug. For example, we are habituated with reading code line by line, right? But in reactive programming style, you'll probably not, you'll not be able to do that, even though you are writing code line by line, but the execution is completely different. So you have to sort of juggle a lot. But in traditional way, basically, it's just simple. The way you write, it's pretty imperative, and it gets executed exactly the same way, and you can easily debug. So the traditional way of doing things has so many benefits, and exactly that's what is we can do or achieve with the new idea, which is virtual threads, which is a new kind of thread we are available since JDK 21. So I'm gonna quickly show you how can we create create virtual sets. It's pretty easy. So that way we create traditional sets. Creating virtual sets is not that different. You just we have few builder pattern. So it introduced in JDK 21. So if you can, mm, use this builder pattern, which is thread.opvirtual, and then you can create two kind of threads. One start method, which is basically if you put anything over here, it's going to be executed by the virtual thread. I'm going to explain how the difference between traditional thread and virtual thread in a minute, but this is how you can create a virtual thread. So if I write anything over here, let me copy this two line from here to here. Sorry about that. So this code is going to be executed by a virtual thread. This get name will not return anything. So I'm just, put current thread over here. And yeah, that's it. So basically thread dot or a virtual dot start. So it will create a virtual thread and then immediately it will start. And if we run this, let's see, if we run this, we haven't, there is nothing over here. The reason is, virtual threads are basically daemon threads. So what happens is main thread started here, right? And it created a virtual thread, and then it doesn't see anything over here, so it exits. Since it's exited, so virtual thread is a daemon thread, so it's also exited. So that's why it didn't print anything. So what we have to do is we have to wait to finish it. So let me name it v1, v1 join. So if I do that now, I'll be able to see how virtual thread. As you can see, it printed, and then we can see the name of the virtual thread, which is virtual thread, and it's run on top of a fork example. I'm gonna talk about in a minute. But this is how we can create virtual thread, and then there is another way of creating virtual thread, which is thread.opvirtual unstarted. In case there is a situation where we need to create a virtual thread, a list of virtual thread, and then we don't want to start immediately, rather we want to start them after a certain condition on whatever programming logic we have, we can do that. So exactly it's the same thing. It doesn't start immediately. So you have to call this unstarted v2 uh, start method basically. Mm. So explicitly you have to call this start method, then it will start. And for this one, it already started, so you don't have to call it started. And if you call it v1.start, it will throw an exception. So you have to be mindful. And then there is another way of creating virtual thread. In case you are always starting immediately, then maybe you don't have to write this additional keystroke. Put additional keystroke, you can just thread dot start virtual thread. So this another method available. It does the same thing. And okay. So now in our production code, which we have been writing for a long time, we have put something like this: executors try per executor new executors fix stateful. We have put something like that in our production code. I'm pretty sure. Pretty much, if we need a stateful, we do something like that. So why? All right. So and we pretty much submit our task over here, and it definitely return us a future, right? And this sort of code is available in our product system a lot. And if we want to move back to virtual thread, what we have to do is we have to just change one line and everything can remain the same, which is in new virtual thread per task executors. Basically, just if you change the one line, everything in this in this idioms it can remain same. And even though it's calling submit, it's not using any full underlying. It's just creating a new virtual thread and executing that task with that virtual thread. So these are the ways we can create virtual threads, and there is a quick demo that I can show you, just to give you an understanding how much throughput we can improve using the virtual threads. So over here, I have a it's pretty much a dummy test. It doesn't do a lot. Basically, we have a service call that takes around 10 milliseconds. So we use Sleep to demonstrate that. And what we're going to do over here is we're going to use two traditional way. One is basically using the fixed state pool. That's the traditional way of creating virtual thread. And the other one is using the virtual thread, which is new virtual thread task executors. Underlying, it's going to create virtual threads anyway. So what the number of thread we're going to use over here in the fixed thread pool is the available processor in this machine. It could be 10, it can be 20, 12, depending on your computer available. So let's say for this particular machine, I believe we have 10 processor available. Let's say we have 10. So what happens is when we create start virtual threads, it use the underlying fork join pool. That fork join pool actually use the same number of threads that the number of available processor you have. So and virtual thread, the thing that I haven't shared with you yet, which is virtual thread is totally Java construct. Operating system doesn't know about anything virtual threads. So basically what happens is we have some traditional threads into fork join pool, which is basically let's say 10. And this 10 thread basically executes all the virtual thread we can create in our it could be million. We can create millions of virtual threads, and it doesn't have any problem. So virtual thread and traditional thread has a one-to-many relation. One traditional thread can execute many virtual threads. So what happens is the relationship is basically something like that. If you see the picture, what happens is OS scheduler basically schedule OS thread, and OS thread has a dependency with one mapping with the Java thread, which is our traditional thread. We can call it native thread. We can call it carrier thread. We can call it platform thread. There are various names we can call it. And on top of that, we have a JDK scheduler, which is basically a fork join pool. So what happens is this fork join pool has a FIFO queue, and when we create a virtual thread, it goes into that FIFO, and this scheduler basically schedule all these virtual threads. So this is what underlying happens. So over here, that means the number of operating system threads remains same for both cases, which is in this particular test, right? Which is the new fixed thread pool, like we have, let's say 10. And if we run the same program with virtual thread, it's all the the operating system thread remain the same, which is 10, because underlying the fork join pool is going to use the same number of threads. So now we have a task over here, which is dummy service call, and we are gonna we have like 10,000 tasks. So what we're gonna do is we're gonna run and see how much improvement we can achieve using the virtual thread. So again, don't take this as a a serious benchmark. It's just to make a point. So as you can see, traditional executors took like this amount of time, and same thing can be achieved with virtual thread with pretty fast, which is 63 millisecond. And you can see we have improved like 99.9 some near 99%. I mean, in traditional, when we're gonna write your application, obviously this is not going to be the number. I'm just trying to make a point that it can improve a lot significantly if you use virtual thread, the virtual thread basically. So yeah, so that's the demo I wanted to show you. And next part is basically we have to keep a few things in mind that I'm gonna go quickly show you. Before that, let me show you that there is a program. I took this program from this YouTube video. I can share this with you all as well if you want to watch that. It is done by um, um, uh, it was a presentation done in J1, Java 1, I think. Yeah. So the idea is how many threads we can create. As you can see over here, I put 10 millions. And if I run this program without impacting anything, even I'm streaming and anything, it will be able to create 10 million threads with a very short amount of time. And I will see in a second how much time it took to create 10 million threads. As you can see, it takes this a little time to create 10 million virtual threads, and we have like 10 ports in this machine in this machine, and it used basically number of 10 platform threads to create all these virtual threads. So that means basically we can create a lot of virtual threads in a short amount of time. So the highlight is if you need a task that you want to run, parallelly or concurrently, you can just create a virtual thread and hand it over. You don't have to use any kind of pull. Um, and So what happens is when in a web applications, let's say you are writing in a web applications and request come, and then request there are a few things can go parallelly. For you may need to call few microservice to result accumulate some data. You need to call a database operation, right? So all of those things, all of these individual tasks can be done using virtual thread, and they can do things parallelly, and then you can accumulate those results and return back that way. And that very request that web application received can be done using virtual threads. In fact, one of the framework called I forgot the name. I think Helidon, Nima or Helidon. They are using virtual threads now, and it's even production ready. So you can use Helidon, Nima, I think. I forgot exactly. It probably Helidon Nima or Hold the Helidon. So I'm gonna send you the link Helidon Nima. It's a Java web app framework that it's a framework for Java microservice based on virtual thread. So you can use that, and they have argued that this has improved a lot, and you don't have to if you need a preference, and you don't need to use the alternative, which is reactive programming. You can use traditional way of doing things. You can use regular imperative code using these virtual threads. So basically, there are other frameworks also, joining. Spring is also trying, and few other framework I believe tried virtual threads. And hopefully, next few years, virtual thread is going to be a regular thing, a regular way of doing programming, a regular way of doing concurrency in Java at least. Anyway, moving on, where I was, okay. So I was trying to give you some caveat as well. One example is, although virtual thread has a lot of benefits, it has a small caveat, which is if you use the traditional, synchronization method, it can pin itself. So what happens is, um, uh, so we have a fork join pool, right? Fork join pool has a limited number of threads, let's say 10. So when we create a virtual thread, it goes into the queue, and JDK scheduler, which is fork join scheduler, pick one virtual thread and it mount on a traditional thread, which we call it serial thread, and it start executing. And then when it sees some sort of blocking operation, for example, you call a network IO, or it goes to sleep or something else, it that very virtual thread can yield itself or unmount itself from the that carrier thread. So when it does unmount itself, it becomes free, and another virtual can take this place and start executing. So that means when you are basically blocked in a particular region, it could be a microservice call or database call. You are not wasting CPU. Your operating system threads are always working like 100% of the time. It's executing another virtual thread basically. So that's what happened under the hood. And the problem is when it works. Um, 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 when it so what happens is when you are um, executing a method, and if it has a native method, or it using some sort of synchronization, then it pinned itself. Basically, it remains pinned. So that carrier thread, the whole time, it will not be able to yield itself or unmount itself. So that's the problem basically. So here's this a quick demo that I'm going to show you over here. What happens is let me explain. So there is a method I have which is synchronized locked, right? So it is synchronized lock. So if I run this code, then I'll able to explain what happens is basically, as you can see over here, it says it's pinned uh, over here basically. So you can and there is a particular flag over here that you can use, which is this one. I have used this flag to demonstrate. So if you use this flag, you can see where this virtual sheet is pinned. And if I remove it, let me remove it for this demo over here. Let me run it. So as you can see, the whole code ran on one carrier thread basically, which is fork join pull worker one, and we definitely don't want that, right? The whole point is, one virtual thread is going to yield itself, and then another one will come immediately. So that's the problem, and this problem can be solved using without synchronization. If you use like lock, for example, where you need to synchronize, you can use the re-entering block or some other kind of block, and that problem goes away. So if we run this program, then as you can see, the same program is done by different thread. One is, for example, over here worker one, and then it came back and it started running on worker two. And if I run it again, you will see a different result every time, 1, 5, 9, 10. So yeah, so you have to keep that in mind, which is if you have a code base where you need to call a native method, or then it's a problem. Or if you have a method that you synchronized keyword, that's a problem. So usually JDK team is trying to minimize this problem as much as possible. By the way, this is not a huge problem when you have a very tiny amount of time that it takes to execute that very method. But if it takes a long time, then it's a problem. So the problem can be solved using re-entering block. And how to find out if your code has a pinning situation, you can use these so this flag, this one, trace pinned thread, you can use that. Or there are other ways you can do, which is you can use JFR, Java what Java flight record basically. So over here I have an example of doing Java flight recorder, and if I run this, and I'll able to see all this information. So as you can see, you can get all this information where when exactly where it pins and how long it was. For example, the duration over here. So these are the ways you can give up your pinning situation, and if you have those, you can just replace with the re-entering block or some other kind of block with a not desynchronization method. And yeah, so that's all I wanted to share. And I think there are some questions over here I can see. If I can answer those now. So one question over here is, if I understood correctly, virtual threads are created on top of created threads. Exactly, that's what it is. It's created. I mean, virtual thread. You can create virtual thread. It is done by a traditional thread, which we call a career thread. Does it mean that we should now only use virtual thread, give given the new feature with virtual threads when our traditional thread use? Okay, so there's a two scenario. Virtual thread is extremely useful when you have a lot of blocking operations. So what do you mean by blocking operation? Let's say you are writing a web applications, and web applications basically that web application is ideal candidate of using virtual thread because it has a lot of blocking operation and a lot of waiting involved. So let's say you are calling a database operation, and if you use the traditional thread and the time it takes to get the result back, there is a significant delay, right? You call you do execute a database operation, and the traditional, if you do it with traditional thread basically wait until it gets the result. So basically, your traditional thread is basically not utilized the whole time. Maybe 20% of the time he's being used, and other 80% time he's just sitting idle. And it's an expensive resource, like I said earlier, right? And we should not waste this expensive resource. Um, so these blocking, that's why we don't want to block, right? I mean, reactive programming is basically non-blocking way of doing things. Now, with the virtual thread, blocking is again a cool thing. You can block as much as you want, and it will just reside on the memory. The virtual thread will reside on the memory because virtual threads are resides in the heap, not the stack, and not the off heap memory. So eh, let's say you create a virtual thread and it sleeps. It just sleeps. It just stays in the memory. It doesn't use or consume the CPU, and you can create millions of them. So if one virtual thread is waiting somewhere in the memory, it doesn't matter. You are still functioning with the other virtual threads. Okay. So when we're going to use traditional thread, if you have a computation, basically, if you have computation CPU intensive work, we're going to use traditional thread, and that's where it works best. You are not going to get any benefits if you use CPU intensive work using virtual thread. So that's the thing. And let's see if we have other questions. So basically, the highlight of this question is if you have a lot of blocking operations and you want to, there is a lot of waiting involved, then you are going to use virtual threads, and it will improve a lot your overall performance and throughputs. But if you have a traditional block CPU intensive work, then you should definitely go with traditional way of doing things. Anyway, let me show you this code base. I'm just giving you a second to read this code. Give you in 30 seconds to read this code. So read this code and tell me which one do you like better. I mean, which code block looks better to you? First one or second one? Just you can type the answer in the comment. Let's say this is the first one, and then this is the second one. Which one do you like? I mean, if you were to write what this two code does is basically it just download 10K images. First one is basically a reactive way of doing things, and the second one is basically doing the traditional way of doing things. Okay. A lot of for example, Drago. I'm sorry if I pronounce your name incorrectly. You said, first one is nicer, I would say. Yes, if you are an experienced developer, you have been doing programming, I would say first one is definitely, first one is nicer. The problem is if you want to go, if you need to debug and if you need to explain this code to a junior programmer, I don't know if you still agree with that. The first one is good. So uh, so basically, first one, I mean, it looks nice. But the problem is it comes with some other downside, which is if you want to debug it, it's going to be a problem. And if you want to explain it to junior developers, it's going to be a problem because you have to first understand how reactive stack works, reactive programming style works. You have to know a bit of functional programming. And the second one is much more easier. You can debug it. You can just put a debug pointer and then debug it, and it's easier to explain. So with this, virtual threads, you are now able to write code like this. It's going to be an imperative, but imperative code and easy to read and easy to debug. So that's the highlight. And if we need to a blocking operation, for example, obviously, downloading image will take time sometimes, and this is a blocking operation, and we don't have problem with that using virtual thread. I mean, we can block as much as one because we can create millions of them. So blocking is again a cool way of doing things. Let's see if we have any other questions. Someone says reactive programming sounds cool, but the coolness and in the name. Okay. Um, okay. Someone says luckily never had the need to do reactive programming. I did a little, not a lot, just to get the idea how it works and to get some experience. But I mean, it's cool. I like functional way of doing things. Functional programming is cool, but again, it has other downside. As I grow, I mean, as a developer, I feel like making things simple. It has much more benefits than making things complicated, and we should you know keep it simple, right? I like that. What do you say? Terminology, which is keep it simple. So I want to definitely keep it simple, and reactive programming definitely does. I mean, virtual thread definitely does that. Let's see if we have. At the end, it depends on what we want to use, either reactive or traditional way. Obviously, it's a choice. The reactive programming is not going to go away any soon. I mean, it's a huge. I mean, reactive. A lot of company already spent a lot of programming hour, money, and everything on reactive programming, and they have a huge product built on top of reactive programming. So they are not going to rewrite these whole things. And maybe in long run, maybe let's say down in 5 years or 10 years, people will use reactive programming a lot less than what now. So yeah, that's the opinion. I mean, there are many other programming languages which may seem difficult for others, right? But if people still use that, so it's end of the day, it's a choice. But yeah, I'm not saying reactive programming is going to go away, but obviously, there is a pros and cons, and I personally feel that the way of doing virtual thread has a lot of pros than cons. Yeah. Okay. There is another question. Okay, I think we are discussing over here, right? I mean, functional access for handling operation on data, kind of data-oriented programming, but with the code that can throw an exception to the nightmare. So anyway, so that's all I have. Let me know if you have any questions over here. A few slides where some of the programming language they are trying to incorporate a virtual thread. Helium Nima, I already said, shared. Spring Boot is also trying. Workers is also trying, and a few other frameworks trying. I believe, in few years, every other programming framework is going to implement virtual threads. There are a lot of API changes. I'm not gonna, I don't have time, so I'm not gonna talk about any of those. But yeah, you can definitely look into that. Um, so I'm going to end with two quotes over here, and then by the Ron Pressler. Ron Pressler is the guy is responsible of implementing these virtual sets. So what he says is virtual sets are cheap enough to have a single thread per task and eliminate many of the common issue with writing concurrent code in Java. And I do agree with this quote, what he says, said. And there is another quote is there aren't any new APIs you have to learn, but you do need to unlearn many habits, such as using thread pools to deal with resource contention. So, using the virtual threads, you are no longer need to use thread pooling. So, those who are using thread pools, it's simple, it's easy API, but at the same time, sometimes you need to tune them, right? And tuning takes works, and it's not easy. So yeah, you no longer need to use thread pool anymore if you are going to use virtual threads. And finally, I have a newsletter that you can follow or subscribe, where I try to write monthly basis about different things. Pretty much the content I write in every month I share, and I also try to cover many questions that many developer has. So yeah, if you want to follow me, keep in touch, and if you have more questions, you can definitely follow on this newsletter. It's on LinkedIn. You can copy the QR code, and I also have a Twitter account where I tweet a lot. Let me um, put it over here so that you can. So let me quickly over here. So this is my Twitter account. It's simple name at Bazlur_Rahman. You can follow that. Let me copy that in the chat. So you can tweet me or send message if you want. Sorry about that. So how do I share that? Okay, in the chat. Okay, so that's all I had for you guys. Thank you very much.